An archaeological team digs beside an ancient salt spring and finds hundreds of clay pots cracked by repeated fire. Thin mineral crusts still cling to some of the broken pieces. The scene looks like an answer frozen in the ground. People were boiling brine here roughly 8,000 years ago. So, was this when humans first started using salt? Probably not. Long before pottery existed, human bodies were already getting sodium from food, mineral water, plants, and the landscape itself. But meals disappear. Drinking usually leaves no direct artifact. Ash can be scattered, mixed, or erased by weather long before archaeologists arrive. Salt has an especially inconvenient habit of dissolving. In a strange way, archaeology is a detective solving a case after the culprit has already vanished into the ground. Those broken pots may not record the first time humans used salt. They may record the first time salt use became too large, organized, and repetitive to disappear completely. That changes the question. We are not searching for one beginning, but three. First came the biological fact of consuming sodium. Then came the deliberate act of seeking salty places or foods. Much later came the organized production of salt as something that could be collected, stored, and carried away. Only the last threshold leaves us a clear archaeological trail. And once salt could leave the spring, it stopped being merely something bodies needed. It became a technology, a trade good, and eventually, a source of power. To answer the title honestly, we have to keep those three thresholds separate. Consuming sodium is not the same as recognizing salt as a useful resource. Recognizing a salty spring is not the same as boiling brine into a portable product. The first threshold belongs to biology. Every human body absorbs sodium from food and water, whether the person understands the chemistry or not. The second threshold belongs to behavior and memory. Someone notices that a spring tastes different, that animals return to a mineral-rich patch, or that certain foods satisfy a recurring need. Then that place or food becomes worth seeking again. The third threshold belongs to technology and organization. People draw brine, heat it, collect what remains, replace broken vessels, gather fuel, store the product, and move it elsewhere. Those three milestones almost certainly happened at very different times. The first is far older than archaeology could ever date. The second may also be extremely ancient, but a repeated visit to a spring rarely leaves an unmistakable signature. The third has a better chance of surviving because production creates durable debris, repeated fire, altered vessels, and concentrated activity. So this video is not asking when sodium first entered a human body. That would be impossible to answer and would confuse a biological need with the deliberate use of salt. The question we can investigate is narrower and more interesting. When did humans begin turning naturally salty places into a repeatable system for making, storing, and transporting salt? Before reaching that evidence, we first need to understand why sodium mattered enough to shape behavior at all. Sodium is not merely a flavor preference. It is a mineral the nervous system and muscles cannot function without. It helps carry electrical signals between neurons, allowing the brain and body to communicate. It plays a direct role in muscle contraction, including the contractions that keep the heart working. It also helps regulate fluid balance around cells. None of these functions began with civilization. They predate agriculture. They predate cities. They predate trade networks. They predate pottery itself. They likely predate our own species, because sodium regulation appears across much of the animal kingdom. That comparison matters. Elephants, deer, and many other plant-eating animals actively seek mineral-rich soil, rock, or water when their diets run short on sodium. A body running low on a necessary mineral can turn an ordinary patch of ground into a behavioral target. That mechanism helps explain why humans may also have paid close attention to certain springs, soils, and foods. But the need for sodium did not create the same problem everywhere. People living near coasts or mineral-rich water may have encountered dissolved salts regularly. Groups eating more fresh meat, blood, or organs may have obtained more sodium directly from food. Communities living farther inland and relying more heavily on plants may have faced different pressures. Season, climate, food preparation, and storage would have changed the balance again. So, the biological need was universal, but the practical solution was local. Not every prehistoric person was wandering around desperate for salt. Many people could have obtained enough sodium without ever producing a visible crystal. That is the first crucial distinction. A body can meet its sodium requirement without treating salt as a separate product. The history of salt therefore begins long before manufacture. But the early stages are almost invisible to archaeology. That invisibility can make the story look younger than it really is. A preserved pot can be dated. A vanished meal cannot. A hearth can mark repeated work. A remembered spring may leave nothing that clearly separates deliberate use from an ordinary visit. The question is therefore not whether early humans needed sodium. They did. The question is when meeting that need became a visible, repeatable human practice. So, where could early humans have obtained sodium before anyone manufactured salt on purpose? The possibilities were more varied than a modern salt shaker suggests. Meat contains sodium. Blood contains it. Organs can carry substantial concentrations of several minerals, including sodium. Some springs and groundwater hold dissolved salts naturally. Certain soils and clays contain concentrated minerals. Some plants accumulate minerals drawn from the ground. In some documented practices, people have also used the ash of particular plants as a mineral source. None of this required a theory of chemistry. People did not need to understand neural transmission to learn that certain foods, waters, or places were worth returning to. Useful behavior often came before a scientific explanation. A group could repeatedly drink from a mineral-rich spring without naming the dissolved substance. They could value a particular food without isolating the nutrient that made it useful. They could remember a salty patch of ground without thinking of salt as a manufactured product. Modern communities that consume little or no separately added salt cannot be treated as perfect replicas of the deep past. Their environments, histories, and diets are their own. But they do demonstrate an important possibility. A human diet can supply sodium without a pile of processed salt sitting beside every meal. We should also resist claims the evidence cannot support. We cannot assume that every ancient group ate organs specifically for sodium. We cannot insist that blood was universally consumed as a deliberate mineral source. And we cannot reduce the value of any food to one nutrient. What the evidence allows is a more careful conclusion. Meeting a biological need, recognizing a useful source, and manufacturing a product are three different achievements. The first can happen through ordinary eating. The second requires observation and memory. The third requires a process. That middle step, learning where salty resources existed, is where the landscape itself becomes part of the story. It also depends on knowledge moving between people. A useful spring matters more when its location is remembered across seasons. A mineral patch matters more when children, relatives, or neighboring groups learn how to find it. No formal map is required. The resource becomes dependable because information about it survives in human memory. That kind of knowledge can exist for generations without leaving a tool, building, or written record behind. Between absorbing sodium and producing salt sits a quieter stage. Call it reading the landscape. Prehistoric people had strong reasons to observe their surroundings closely. They tracked animal footprints. They recognized the routes herds used across a territory. They remembered where seasonal water appeared and disappeared. They noticed unusual colors in exposed soil. They learned which plants grew in distinctive patches of ground. And they watched where animals repeatedly stopped. Animals actively seeking mineral sources is well documented. Prehistoric humans noticing those patterns and revisiting similar places is plausible, but much harder to prove directly. We should not invent one dramatic discovery scene and present it as history. There is no record of a particular hunter following a particular deer to the world's first salt lick. But the broader sequence is easy to imagine, without pretending it is certain. Animal tracks converge on mineral-streaked ground. A small spring leaves a pale edge as water evaporates. People taste the water, remember the place, and return when they pass through the region again. Long before maps were drawn on paper, human groups carried working maps of water, herds, stone, plants, and minerals in shared memory. A salt lick does not come with a sign, a star rating, or a pin on a map. Its value depends on someone knowing it exists and remembering the way back. That knowledge is already more than accidental consumption. It turns a scattered natural resource into a dependable destination, but it does not yet free people from the destination. As long as the useful mineral remains dissolved in a spring or fixed in one patch of earth, access depends on reaching that exact place. The next threshold appears when people learn to separate salt from its source, concentrate it, and carry it away. That change is easy to underestimate. A remembered spring is a place people must reach. A container of concentrated salt is a resource that can reach people. The geography of access begins to reverse. Instead of the community always moving toward the mineral can finally move toward the community. This is where the story reaches its strongest physical evidence. Picture a shallow basin of pale, cracked ground beside a natural brine spring. Blackened stones and hearths cluster nearby. Broken ceramic vessels lie scattered through layers built up by repeated activity. At Neolithic sites in what is now Romania, evidence points to people heating salty water during the 6th millennium BCE, roughly 8,000 years ago. The details vary from site to site, so no single location should be treated casually as the unquestioned first in the world. But the larger pattern is clear enough to matter. People drew brine from natural springs. They poured it into ceramic containers. They heated those containers long enough for water to evaporate and mineral residue to remain. Then, they repeated the process. Someone had to gather fuel. Someone had to make or obtain the vessels. Someone had to tend the heat. Someone had to collect the residue and decide what happened to it next. The broken pots are important because repetition leaves a signature. One shattered vessel could be an accident. A few hearths could have served many ordinary purposes. But large concentrations of heat-damaged pottery near brine sources suggest an activity carried out again and again. That activity required practical knowledge. People had to learn how much brine a vessel could hold. They had to manage heat without losing every container immediately. They had to recognize when evaporation had gone far enough. They had to replace equipment and repeat the cycle. The result was not merely salty water consumed at the spring. It was a concentrated material that could be collected, stored, divided, and carried elsewhere. Similar brine processing evidence has been discussed in other regions, including parts of China, though the surviving record does not justify a simple race for one universal first. The responsible conclusion is narrower. By roughly 8,000 years ago, some communities had clearly developed repeatable methods for producing salt from brine. That does not tell us when humans first tasted salt. It tells us when salt production became organized enough to leave a durable archaeological footprint. Drinking from a spring uses a resource where nature placed it. Boiling brine turns that resource into a technology. Carrying the residue away turns the technology into a supply system. And that system emerged while human communities were changing in other fundamental ways. The significance lies less in one dramatic invention than in the coordination behind it. Evaporation itself is simple. Keeping the process going repeatedly is not. Repeated production links landscape knowledge, pottery, fuel gathering, heat control, labor, and transport into one chain. A failure at any point slows the entire operation. That is why the debris matters. It records not only a chemical result, but an organized pattern of human work. It is tempting to reach for one tidy explanation. Farming happened, so salt production happened. That is too simple. Several changes were likely unfolding together, and none of them explains every site by itself. Start with diet. A heavier reliance on cultivated grains could alter how much sodium people obtained naturally from food. Then consider mobility. A mobile group could adjust its route or return seasonally to a known mineral source. A settled community had less freedom to reorganize life around one distant spring. Then consider population. More people living in one place needed supplies that were regular and predictable. Then consider storage. Settled communities had growing reasons to preserve meat or fish, prepare for lean seasons, and move food across time as well as distance. Then consider specialized labor. Salt production becomes easier to sustain when some people can shape vessels, gather fuel, manage fires, transport brine, and handle the finished material. No single factor forces a community to manufacture salt. Together, however, they can transform an old biological need into a logistics problem. That is a different kind of challenge. It requires scheduling. It requires containers. It requires fuel. It requires labor. It requires storage and distribution. Agriculture did not create the human need for sodium. Nor did every farmer suddenly become sodium deficient. Salt production was not invented everywhere for one identical reason. The more careful conclusion is that settlement and food production may have changed the scale and predictability of demand. Once communities stayed in one place, old needs had to be solved through organized systems rather than occasional encounters. At that point, salt was no longer only a mineral found in food, water, or soil. It was becoming a managed resource. And managed resources have a habit of changing social relationships around them. A spring can belong to a landscape. A production site can become part of a community's routine. A stored supply can be counted, guarded, shared, exchanged, or withheld. The mineral itself has not changed. Human organization around it has. Follow the chain far enough, and a pattern appears. Need leads to seeking. Seeking can lead to production. Production makes storage possible. Storage allows transport. Transport opens trade. Trade invites control. Once salt could be separated from its natural source, everything about its social value changed. People living far from a brine spring could still gain access to it. A finished supply could be held for later, rather than consumed immediately. A community could exchange surplus salt for materials it lacked. Control of a reliable source could give one settlement leverage over its neighbors. And whenever a society organizes the supply of something widely needed, power tends to gather around the system. Much later in history, states in parts of China controlled and taxed salt because demand remained dependable. That example belongs to a far later political world than the Neolithic brine sites, but it reveals the long-term consequence of the same transformation. A natural mineral had become a product that could be measured, moved, restricted, and taxed. The point is not to tour every civilization that ever traded salt. It is to notice what happens when a biological need enters a distribution network. Whoever controls the network can influence who receives the resource and at what cost. Now, compare that ancient search with daily life today. Most people no longer visit mineral springs or study animal trails to find sodium. Salt arrives already mixed into bread. It is folded into cheese. It appears in preserved foods, sauces, and packaged meals before they reach the kitchen. This is not a lecture about how much salt anyone should eat. It is a comparison about visibility. In the deep past, sodium could be present in a diet without appearing as a separate manufactured product. Today, manufactured salt is so deeply embedded in the food system that people may consume it without actively seeking it at all. The search has disappeared because the supply network became almost impossible to see. And that brings us back to the broken pots that made the ancient system visible. So, when did humans first start using salt? The honest answer depends on which kind of use we mean. Humans absorbed sodium from food and water long before any archaeological evidence of salt production. There is no date for the first salty taste. There is no recoverable moment when someone first returned to a mineral spring or recognized a salt-rich patch of ground. Those behaviors rarely leave evidence strong enough to identify a beginning. By the 6th millennium BCE, roughly 8,000 years ago, some communities were clearly boiling brine in a repeated and organized way. That is one of the clearest early markers for salt production as a distinct process. It does not mark the beginning of the biological need. It probably does not mark the first deliberate search for something salty. It marks a later threshold, when a natural resource had become a technology and a portable product. Now, return to the excavation. The broken vessels survived because pottery is durable and because people discarded it in large quantities. Meals disappeared because they were eaten. Water soaked away. Soft tissue rarely remained recognizable. Salt itself dissolved, moved, and returned to the ground. Archaeology does not show everything that happened. It shows what happened to leave a trace. That gap between the past and the surviving evidence matters far beyond this one question. Earliest evidence is not the same as first event. Sometimes history cannot record the moment a behavior was born. It records the point by which that behavior had become repeated, organized, and material enough to resist disappearance. The need for sodium was ancient. The search for salty places may also have been ancient. The evidence of organized production came later. By around 8,000 years ago, salt had clearly become a repeatable system. And in the surviving record, That system had finally become durable enough to enter history.